Welcome to the deep dive. In this deep dive, we're unpacking something really cool, especially if you're building web interfaces. We're digging into some source material, looks like excerpts from a YouTube masterclass all about a library called motion.dev.
That's right.
It's focused on bringing, rich, engaging animations to life, particularly if you're using tech like React or Next.js.
Yeah, exactly. And our mission here really is to cut through maybe some of the setup and code examples in these sources and just pull out the core ideas.
The key techniques.
Yeah, the key techniques, the power behind it, helping you understand what this library really offers for making, well, better user experiences.
So it's like getting the essential nuggets without needing to watch the whole thing. We've got quite a few interesting details, some specific examples from the source to walk through.
Definitely. Let's get into it.
Okay, so first things first, what's the basic idea? What is motion.dev actually for? What problem is it solving?
Right. So the core problem it's tackling is making animations on the web, well, easier and more declarative, especially when you're working inside frameworks like React.
Okay.
The fundamental concept the sources show is you take a normal HTML element, could be a div, an H1, an image, even an input, really anything, and you turn it into a motion component. You just stick motion
Yeah.
right before the tag name.
So div becomes motion.div.
Exactly. H1 becomes motion.h1 and so on.
Right.
It's basically telling the library, hey, I want you to manage the animation for this thing.
Ah, okay. So you're flagging it, like giving it animation superpower.
That's a good way to put it.
Yeah.
You're empowering that element. And once you've done that, once you have a motion component, the sources immediately jump into the sort of three bedrock props you need to know. Initial, animate, and exit.
Right. Initial, animate, exit. Those sound like the core building blocks.
They really are. These three props define the whole animation story, the life cycle for that component.
Okay, let's unpack that life cycle idea. How does that actually work in practice?
It's pretty intuitive, actually. The initial prop that defines how the element looks before it even shows up, before it's in the DOM or right as it's about to enter, it's the starting point.
So like maybe positioned off to the side or maybe opacity, zero, so it's invisible.
Precisely, that kind of thing.
Yeah.
Then you've got the animate prop. That describes the target state.
Where it's going.
Yeah, where you want it to end up after that first animation, or, the state it should move to when things change later on. You put your CSS style properties there, X, Y, opacity, scale, rotate, and the library figures out the smooth transition from initial to animate.
Okay, so initial is the before, animate is the after or the current active state.
That's a great way to think about it. And then the third piece is exit. And this one is specifically for the animation that plays when the component is, well, leaving, when it's being removed from the React tree or the screen.
Ah, that's crucial, isn't it? For things not just popping out of existence.
Totally. It's key for those smooth unmounts, making it clear something is gone. The source material really emphasizes how important that visual feedback is for the user experience. You see something smoothly disappear, you know it's gone.
Right. Okay, so the source shows some simple examples, like animating a yellow circle. How do you make just a basic move happen with these props?
Yeah, the most straightforward way shown is just using that animate prop. You give it an object, and inside that object, you list the CSS properties you want to change and their final values.
So like?
So for example, on your motion.div, you'd put animate x200, and boom, the library animates it from wherever it started on the x-axis over to 200 pixels.
Just like that. You declare the end state, and motion.dev does the work to get it there smoothly. That seems really efficient.
It is. It saves a lot of manual calculation. But, sometimes you want more than just a simple start to end. What if you want something to, say, bounce or cycle through a few different colors?
Ah, right, like a sequence of steps.
Exactly. And the sources show how you handle this using what are often called keyframes, basically arrays of values.
Okay, now this sounds interesting. How does that keyframe array thing work?
So instead of giving a single target value, like x200, you give an array of values for that property within the animate prop.
An array.
Yeah. The source has a great example for a bounce. Y, 0, negative 100, 0, no. The element starts at Y0, animates up to negative 100 and then back down to 0.
Oh, I see. It just steps through the array.
Exactly. Or for colors, you could do like background color, hashtag 00, hashtag 00000, hashtag 00f, and it would animate from red to green to blue sequentially through the list.
That's pretty powerful for more complex movements without writing tons of code.
Definitely. But then things get even more organized when you start dealing with more complex components or groups of elements. The force introduces a concept called variance.
Variance. Okay, what's the purpose of variance? What problem are they solving?
They really help manage complexity. Imagine a button that has different looks when it's idle, when you hover over it, and when you click it. Instead of cluttering your component's animate prop with conditional logic,
Right.
you define these animation states outside the component, giving them names. Like, you could define a hidden variant, a visible variant, a hover variant, maybe a tap variant.
So you predefine these animation recipes.
Exactly. You package them up. Then, in your component, you just use the animate prop to say which variant name it should be animating to, like animate visible or animate hover.
Mm.
The source shows a box changing scale, rotation, and skew using variants named initial, hover, and click.
Ah, that makes a lot of sense. It cleans things up, keeps the animation logic separate from the component structure. Seems much more maintainable.
Totally. It scales much better. And then another common scenario the source covers is when you have, say, a list of items or a grid, you often don't want them all to just pop in at once.
Yeah, that can look a bit abrupt.
Right. You want them to animate in sequence. That's where staggering comes in.
Staggering, like delaying the animation for each child element.
Precisely. You put a special prop, stagger children, on the parent motion element, like a motion.ul or a motion.div that wraps the children.
On the parent, okay.
Yeah. And you give it a time value, say stagger children, 0.1. This tells the parent, when you animate your children in, wait 0.1 seconds between starting each child's animation.
Oh, cool. So it creates that ripple or cascade effect automatically.
Exactly. The source shows this with like an image gallery where images fade in one by one, or a list where items slide in sequentially. It's a really simple way to get a very polished effect.
That seems incredibly useful for lists and grids, just one prop on the parent. Nice.
Yeah, it simplifies that orchestration a lot.
Okay, so we've got basics, keyframes, variants, staggering.
But a lot of modern animation is interactive, right?
Wait.
Reacting to the user. How does motion.dev handle things like scrolling or dragging?
This is where things get really interesting, and the library provides hooks. The sources highlight, use a scroll, and use transform.
Hooks, okay, like React hooks. Yep, exactly. Use scroll lets you tap into the user's scroll position. It gives you back these special motion values that track scroll progress, maybe within the whole page or just a specific element.
So you get a live value representing how far down the user has scrolled.
Kind of, yeah.
Yeah.
It's often a progress value, like 0 to 1. And then, use transform is the magic bit. It lets you map that scroll value range to another range for an animation property.
Whoa, okay. Explain that mapping part.
Sure. So imagine you want an element to fade in as you scroll down the page. Use scroll gives you the scroll progress, say from 0 top to 1 bottom. Use transform takes that 0 to 1 input range and maps it to, say, an opacity range of 0 to 1.
Ah. So as the scroll value goes from 0 to 1, the opacity automatically goes from 0 to 1.
Exactly. The source shows a scroll indicator bar whose width animates from 0% to 100% based on scroll progress using this exact technique. Another example maps scroll wide position to both scale and border radius at the same time.
That is super powerful for creating those dynamic scroll-linked effects without manually tracking scroll events and calculating styles.
It really abstracts away a lot of complexity. And then there's dragging. The sources show it's often as simple as adding a drag prop to your motion component.
Just drag.
Yeah, like drag X to allow dragging only horizontally, or just drag for free dragging. It makes the element draggable right away.
That's handy.
Very. The sources also briefly touch on use motion value. This seems a bit more advanced maybe for lower level control.
How so?
Well, it lets you create these special observable values that animations can be driven by or that you can react to programmatically.
Yeah.
The source example seemed more about debugging, but you can see how you could use it to, say, link the drag position of one element to the rotation of another or something custom like that.
Gotcha. So it's there if you need really fine-grained programmatic control over animation value.
Exactly. And tying it all back, the sources also make it clear that integrating with regular component state like React's use state is totally seamless.
How does that work?
Well, you can have your component state, maybe a Boolean for whether a toggle is on or off, or a number for the current slide in a carousel, and you use that state to decide which variant should be active or to calculate the target value for the animate prop.
Ah, so state changes drive the animations.
Precisely. Like in a toggle switch example from the source, changing the is-on state triggers an animation between the on and off variants, or a flip card where state determines if it's flipped or not.
Okay, so putting it all together. The source material walks through building several complete examples. Which ones really stand out for showcasing how you combine these different techniques?
Yeah, the interactive card example is a good one. It combines a couple of things. It uses while in view.
While in view, what's that?
It's a prop that triggers an animation specifically when the element scrolls into the viewport. So the card scales up or fades in only when you actually scroll to it.
Oh, nice. Scroll-triggered animation.
Yeah. And then on top of that, it uses while hover to add another effect, like maybe the card scales up a bit more or changes background color when you mouse over it.
So you're layering scroll-triggered animations and hover interactions. That's pretty neat.
Exactly. It shows combining different triggers.
Mm-hmm.
The carousel example is also really illustrative.
How does that one work?
It uses standard React use state, to hold the index number of the current image, right?
Okay.
Then the animate prop on the container holding all the images uses that index.
Mm-hmm.
It calculates the X position it needs to shift to basically negative index times image width. And motion.dev handles the smooth slide transition whenever that index changes.
So state changes directly drive the X property in animate. Cover.
Yeah. And the progress steps example is great too.
Yeah.
Again, state tracks the current step number.
Right.
And that state directly controls the width of a progress bar element,
Ew.
animating the width based on like current total steps.
Yeah.
Plus, the state changes the color of the step number indicators and maybe even transitions the content shown below the steps.
So it's using animation as a really clear visual guide through a multi-step process.
Yeah. Exactly. It's functional animation. And even the simple toggle switch. It's a nice little contained demo showing state-driving variants, maybe with a nice spring transition effect for that bouncy field the source mentioned.
Okay. Wow. So let's try and connect the dots here. For you, the listener, trying to quickly get up to speed from these sources, what's the big takeaway? What does this all mean?
I think the main takeaway is that a library like motion.dev provides these really powerful high-level tools, abstractions, really, that let you create sophisticated web animations without getting bogged down in the nitty-gritty details you'd face with just, say, CSS transitions or raw JavaScript.
Yeah, it feels like it gives you these ready-made building blocks. You've got the basic motion elements, the core initial animate exit lifecycle.
Right.
Then these concepts for handling complexity like variance and staggering. And finally, the hooks like use a scroll and use transform to connect animations directly to user interactions.
Exactly. And the sources really show that by combining these fundamental ideas, you can build a huge range of effects, from simple fades and bounces, like we saw, all the way to complex interactive things like carousels or elements that react dynamically as you scroll. It just shortcuts so much of the manual effort.
Yeah, the manual effort of managing timing, easing functions, state transitions. It seems to handle a lot of that for you.
It does. The key seems to be understanding these core concepts, how they fit together, rather than memorizing every single line of code.
Okay, we have definitely covered a lot of ground in this deep dive looking at motion.dev. We went from the basics, turning elements into motion components, that initial animate exit cycle, through handling more complex scenarios with variants for named states, keyframes for sequences, staggering for lists.
And then making things interactive with hooks, like use a scroll, use transform, and the drag prop.
Yeah, and we saw how these pieces come together in examples like those interactive cards, the state-driven carousel, the progress steps.
Right. All showing ways to add that layer of polish and responsiveness.
Yeah.
Making web apps feel more dynamic and hopefully improving the user experience.
It really does feel like a powerful toolkit for adding that dynamism without, pulling your hair out.
It certainly aims to streamline that process, yeah.
So to leave you with a final thought, building on everything we've just discussed, we've seen how motion.dev, based on these sources, makes animating individual components reacting to state and handling interactions like scrolling pretty manageable. So what possibilities start to open up if you take these same ideas, these concepts of animate, exit, variance, maybe even layout animations, and start thinking about orchestrating transitions not just within components, but across entire page views or application layouts?
That's an interesting question. Definitely something to chew on as you explore this stuff further.